The advancements we've seen over the years in 3D printing filament never cease to amaze me. And this is one of the more interesting ones we've tested in a while. This is Roamr from Siraya, a foaming TPU that's been specifically designed for footwear. At first, I was a little hesitant to cover this material because we've looked at footwear-focused filaments before. But after digging into it a bit more, I realized this is a very different kind of material. Instead of printing like a typical flexible, it foams while it's extruded, expanding into something much lighter and more cushion-like than a typical TPU. And the interesting thing is that it's not just soft, it has a noticeable rebound, almost reminding me a bit of a PCBWay, which is something not typical from a TPU. In this video, we'll dive into Roamr. We'll cover what the material is, what's required to print with it, and I'll share my overall thoughts based on my time with it so far. So with all that being said and without further ado, let's get right into today's video. Let's start by taking a closer look at what the filament actually is. As mentioned, Roamr is a TPU blend that contains an additive which causes the material to foam as it's extruded. This foaming behavior is something that's been around for a while, and about 4.5 years ago we actually tested out foaming ASA right here on the channel. One of the main benefits of this is that it results in a lighter part due to the reduced material density. And for something like Roamr, which is aimed at footwear, that directly impacts the overall comfort of the printed part. Roamr comes in two configurations. There's an 80A and an 85A variant. These values refer to the material's shore hardness, which is simply a measurement of the material's resistance to indentation. If you're unfamiliar, the higher the number, the harder the material. It's important to note that there are also a few different shore hardness scales, but the one we are specifically interested in with this material is the A scale. Normally, the shore hardness of a TPU would be the same on the spool as well as printed, with the main difference in softness coming from things like wall layer as well as infill density and infill pattern. However, with Roamr, the temperature you print the material at has a direct impact on the resulting shore hardness. Since the material foams more at higher temperatures, you can actually tune the softness based on your print settings. For the 85A version, the recommended print range is 230 to 260 Celsius. At the low end, you're getting something close to its rated hardness, around 83A. But as you increase the temperature and get more expansion, that drops all the way down to around 70A. For the 80A version, the temperature range is the same. But at 230 Celsius, the printed material retains the starting shore hardness, and at 260 Celsius, it gets as low as 66A. Since the amount of foaming is controlled by your print temperature, you'll need to adjust your extrusion multiplier or your flow rate using the table provided by Siraya. This is needed to prevent overextrusion, which would impact the part's overall dimensional accuracy. As a general rule of thumb, the softer the TPU on the spool, the more challenging it's going to be to print with. So if you don't need to go all the way down to the softest shore hardness of 66A, I would recommend going with the 85A variant.
Today's video is brought to you by PCBWay. With over a decade of experience, PCBWay offers high-quality PCB prototyping and fabrication solutions. Along with PCBs, they also provide CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I've used PCBWay for a range of projects over the years, including small batches of PCBs, plus CNC and SLM parts for custom printer builds. I've always been really impressed with their quality and super fast turnaround times. If you're working on your own project but need some help bringing it to life, check out the link in the description below to see everything PCBWay has to offer, and to get $5 off your first order today.
Now that you know a bit about the material and how temperature impacts it, let's go through what's actually required to print with it. The good news is that Roamr is just a TPU, and the foaming properties of it don't actually happen until after the material's extruded, meaning that the printing requirements and parameters are going to be very similar to just any typical TPU. We've already touched on the required printing temps, and just about any hot end will do. What's more important than the hot end is the extruder as well as the filament path. You want a printer with a direct drive extruder that has a constrained path between the extruder and the nozzle, as well as the distance from your spool to where it's going into your toolhead to be as short as possible. Most direct drive extruders still use a filament guide tube from where the spool is mounted on the printer. This tube is made of PTFE or Teflon, which is slippery and has extremely low friction, making it a great choice for a lot of filaments. However, in the case of TPU, this still introduces drag or friction, so you want to limit the amount of Teflon or filament guide tube that you're using. My original plan was to use the same top-mounted spool holder that I used on the H2D when printing with other flexible filaments. But Siraya recommended that I print directly from a dry box, especially for longer prints, to prevent any sort of issues from moisture being absorbed into the material. So I printed out a rack for the top of the printer that holds the poly dryer box. I then cut just a short snippet of PTFE for the toolhead and for the poly dryer box to prevent any unnecessary friction. TPU is a filament that's notoriously hygroscopic, so even though these filaments were brand new and in a vacuum sealed bag, I still opened them up and dried them out overnight before I went ahead and printed with them. For your bed, the recommended temperature for printing with Roamr is between 35 to 50 Celsius. I pretty much exclusively use powder-coated PEI, which sticks incredibly well to TPU, and I've had no issues with adhesion all the way down at that 35 Celsius temperature. One lesson I learned the hard way is that when printing on PEI with flexible filament, you need to use a release agent if you ever want to get the part off without damaging your bed. The easiest one to find, and what I've had good luck with, is just a standard glue stick. On an untreated bed, I do 2 passes, one horizontally and then another one vertically. You don't need to use very much pressure because the texture of the bed grabs onto the glue. And if you have some sections where there's a little bit more glue than others, don't worry about it. As soon as the bed starts to warm up even a little bit, it will all even itself out. For cooling, you want to use 100% to help minimize sagging and stringing as much as possible. Siraya also recommends setting the retraction to 0 because of the foaming property. They state that retracting doesn't do much for stringing, but if you have too much retraction on, it could lead to clogs or jams, so the recommendation is just to turn it off completely. One thing that I've said multiple times that I really appreciate about Siraya is that they provide material profiles for their filaments. Yes, you can easily take the provided settings on their product page and create your own profile, but having them available to just click and download makes getting up and running just that much easier. As far as I can tell from comparing them, the profiles for the 80A and the 85A version of Roamr are identical, with the only differences being in the temperature as well as the extrusion multipliers. I started out by downloading the profile for the H2D and opened it up to take a look. The settings in the profile were right in line with their documentation. However, the max flow rate was capped at 4 cubic millimeters per second, which is definitely slower than what I was expecting. I figured this was likely set so low to ensure consistent results on a range of different parameters, so I kept everything as is. I requested some links to the models that they had shown on their product page and started off by slicing out and printing out one of the sandals. TPU supports bond together and oftentimes will damage the part they are connected to when you try to remove them. So I loaded a spool of PLA into the other hot end on this printer, checked to make sure that the Z distance gap for the supports was set to 0, and fired off this 33-hour print. Over the next 2 days, I monitored this print on and off, and for the most part, things were pleasantly uneventful. The only real issue was lots of stringing caused by a retraction set to 0 and the foaming property, which on the H2D caused the filament spaghetti detective to pause the print a couple of times, which ended up making the print take a bit longer than it initially should have. After the second time it triggered, I ended up just disabling the spaghetti detective, and then I had no more false triggers for the rest of the print. While this print was going, I also set up the Snapmaker U1 with a print. I played around with how I wanted to feed the filament in and ended up going with a setup sort of similar to what I did on the H2D. The filament was printed straight from the poly dryer, stacked on a few spools of filament. And I used a bit of PTFE both at the dryer and at the tool head. I originally started the print without any PTFE at the tool head, but due to the softness or sag of this filament, it ended up finding its way in between the dock and the tool, which gave me a couple of errors. And so by adding just a bit of PTFE to elevate the filament, it completely removed any of those docking errors I was getting. I went with a different shoe model on this printer and stuck with PLA for supports. I did, however, bump the max flow rate up from 4 to 6 cubic millimeters per second and gave it a tiny bit of retraction at 0.2 millimeters. Outside of the heavy stringing, both prints completed with minimal issues. The strings on the sandal were easy to clean up by just pulling at them, and then I think I used also just a pair of needle nose pliers to grab some of the smaller strings. And on the shoe model, I largely just pinched and pulled off any of the bits of strings that had gotten stuck onto the shoe during the printing process. I was thrilled with how well the PLA supports did. I have done some tests in the past, so I knew very well that PLA and TPU are a great option for supports, but this was by far the most extreme stress test I'd ever witnessed them under, and they stuck really well. Nothing separated during the printing process, but if I pinched and pulled, I was able to get a clean separation. The finished sandal turned out awesome. The texture and hardness of the material makes it feel almost like a foamed rubber. It's pretty solid, but still has some give and compresses nicely when you push on it. The shoe model is an interesting one. This one is designed with no walls and just a rectilinear infill pattern for the entire thing. This, combined with it being in the softer of the two Roamr variants, also printed at 250 Celsius, makes it very squishy. I did happen to get 2 small tears at the top of it during printing. These were supposed to be for my 3-year-old, but I sliced them up very late, and somehow my scaling made them too large for my wife and too small for me. And when I attempted to shove my foot inside of them just to see how they felt, I turned one of those small tears into a large tear. As for the sandal, the length was spot on for Aaron, but the width was just too skinny, so I ended up just printing out the one sandal instead of printing out a second one that also wasn't going to fit properly. Learn from my mistakes, and if you're planning on printing out any sort of footwear, double, triple check your measurements. Even if you scale things according to a table that's in the model's slicing or description, I recommend grabbing the measurement tool in the slicer and just double checking things like lengths and widths before you spend 33 hours printing out something that doesn't fit. After printing out the sandal and the squishy shoe, I wanted to do a bit more testing. So I printed out 4 cubes in the 85A Roamr material using the range of temps and flow rates recommended by Siraya. Shortly after starting that first batch, I realized that I did not slice it at 100% solid infill, which I anticipated would have an impact on the shore hardness reading I would get from them, but I also wanted to confirm that this was actually going to be the case, so I let one batch of them print out with roughly 27 to 30% infill, and the second batch print out at 100% solid infill. Well, I was correct about the non-solid prints, and the range I got back when measuring them was from 62 down to 44A. Since this test is based on how the material resists indentation, any gaps or internal structure from infill will affect the results. For the pieces I printed solid, the measurements I got were near spot on to what Siraya provided in their product info. The last thing I wanted to print out was the Airless tennis ball I printed out some months back in both PEBA and a standard TPU, and the results didn't disappoint. It's lightweight, has pretty good bounce, and leads me to my conclusion about this material. Based on the product page and the marketing surrounding Roamr, it's clearly designed to be used for footwear. And based on the couple of samples I've printed, I can see why. The sandals specifically with the 85A variant, I would absolutely rock these around the house if they were bigger, or even just somewhere if I was kind of out lounging. For the shoe, I would be scared to wear anything that's hollow like this outside of the house. Maybe I could see myself rocking these like slippers in the house, but more so than a shoe, the thing I'd be interested in is designing or printing out custom or replacement insoles for some of my existing shoes. But beyond footwear, I can see a ton of additional applications for this type of material. From custom inserts, to bumpers, to even RC plane and drone parts, the lightweight rebounding functionality of this material makes it quite unique. It is worth mentioning that Siraya has also released 2 other foaming flexible filaments. You have PEBA air as well as TPU air. So if you're interested in a foaming flexible material, I would check out this one along with those other two to see which is going to be the best for your specific application. I haven't gotten hands-on experience with the other two versions to give sort of a direct comparison, but based on what I'm seeing on the product page and reading, it seems like Roamr is sort of a good happy medium between the PEBA air as well as the TPU air. With it, you get some of the bounce of PEBA, but with a bit more of the cushion than you'd get with a traditional TPU. And that's been Roamr. I hope that you enjoyed this video and that you have a much better understanding of what the material is, what's required to print with it, and sort of what the results are that you can expect from printing with, I'm going to say these materials. It's a single material, but in two variants. If you have any additional questions, let me know in the comments down below, and I will do my best to answer. As always, if I don't know the answer to your questions, I have no problem reaching out directly to Siraya Tech to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every other week, so there's always fresh content coming your way. And if you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys.